Hello, everyone, and welcome to this is going to be sort of a challenge type problem, and this is going to be a good problem for you to work for your test coming up. So here's our situation. We have a flat frictionless surface, and on this surface we have two blocks. I'm going to call them block A, and then I've got another block here, block B, and they are in contact with each other. And I am pushing with a force of, I'll call this Fp. I am pushing with a force of 10 newtons. Okay? And the acceleration of this system, in other words, both blocks together, okay, so I'm pushing them, they remain in contact, and the acceleration is 2 meters per second squared. Okay, and again, this is a frictionless surface, so Fk equals 0. All right, now the mass of A, it is 4 kilograms. And the mass of B is 1 kilogram. Okay, now each part of these problems that I'm going to do, each part is going to be worth half an extra credit point on your next test. So you're going to have two problems here, each with two parts. So that's, well, my line drifted a little bit. That's okay. So each problem is worth 1 point in a sense on your next test. So 2 points up for grabs here. And here's what I want. On part A, I want a free body diagram for each block. Okay. Now, you have to have correct direction, and you also have to have correct labeling. Okay. Remember that your frictional force is 0. Okay. Now, in relation to part A, part B, I want you to find out what is, the normal force for two things. For block A against B, in other words, what is the magnitude of the normal force felt by B? And I also want to know what's the magnitude of the normal force felt by A. This kind of leads me to Newton's third law. Remember, every action has an equal and opposite reaction. This is kind of going to show you how that works out. A little hint for this, Newton's second law, force equals mass times acceleration. And think about it, you know the acceleration of both blocks, which means that each block is accelerating at 2 meters per second squared. So think about that. Okay, so we'll call that problem 1. Problem 2 is the same setup as before. We've still got a frictionless surface. We've got our two blocks, we don't have a frictionless surface now. And so here we go. The force due to friction on block A, okay, is 12 newtons. The force due to friction on block B is 3 newtons. Okay, and I am now pushing with a force of 20 newtons. 20 newtons. Now, each block has the same mass as before. So A is 4 kilos, B is 1 kilo. And now here's what I want to know. Part A for this problem, what is the acceleration of the system. Okay. Part B, I want the same as for the last part B. What is the magnitude of the normal force felt by B? What's the magnitude of the normal force felt by A? Okay, so there is your challenge problem. It's going to be due tomorrow because we're going to go over it tomorrow and kind of use this to tie into our friction lab.